Scenario: an amusement park ride has identical carriages that revolve around the center of the ride's axle, as shown in the figure. Both carts travel at a constant tangential speed at all points along the circular path with the radius of big R. Two friends that weigh the same are on separate carriages. Friend A is on carriage 1, which is on top of the circular object, and friend B is on carriage 3, which is on the bottom of the circular object. As friend A carriage passes through the top part of the ride, he feels the seat exerts a normal force with the magnitude of 0.6 force of gravity. Question: at the same time, what is the normal force that friend B feels when he is at the bottom part of the ride? A lot of you will think they are the same. It's not. Let's take a look. Here's the answer. We'll start by looking at the free body diagram. So at the top, force of gravity is pulling it down, and force normal is pushing it up. So here, the centripetal force, Fc, is made up of two forces, Fg, which is positive because it's pointing towards the center of the circle, minus Fn, which is pointing away from the center. This is the centripetal force equation at the top of the loop. I substitute in that force normal that we have, so 0.6 Fg. Then, notice there's a 1 in front of the Fg here. So 1 minus 0.6 gets you 0.4 Fg. This is very important because this tells you that anyone on the ride, no matter where they are, will feel a centripetal force of 0.4 Fg. Now, we did this so we can now look at the friend that is at the bottom of the ride. Fc, which is the centripetal force at the bottom of the loop, has Fg pointing down and Fn pointing up towards the center. So the Fc is different at the bottom of the loop. It's Fn minus Fg. Now we can plug in the centripetal force of 0.4 Fg because we showed that anywhere in the circle they should still feel the same centripetal force. Now we can add Fg to the other side because we're trying to solve for the normal force of that friend, which is at the bottom of the ride. So 0.4 Fg plus Fg would be 1.4 Fg. That is the normal force. This should show you that at the bottom of the ride, the friend is actually feeling more because the force normal at the bottom is greater because that force of gravity is actually adding to it. Okay? What I mean by adding is because if you look at the third step, is 0.4 Fg plus Fg is equal to Fn. All right? So this is the way you should think about it. At the bottom, the friend will actually feel more of the force normal because again, the force normal is actually what is supplying the centripetal force, causing the object to remain in the circle. But at the top, notice it is Fg that is supplying it. Okay, that is why the person feels a less force normal. Okay, there you go.